Yeah,
Benji, do you want to kick us off?
I will. Hey everyone, I'm Benji Lampel. I'm an airflow engineering advocate here at Astronomer. Um, Kenton, would you like to introduce yourself?
Yeah, hi guys, I'm Kenton Danis. I'm a lead developer advocate at Astronomer.
Today we're going to be talking about writing DAGs with decorators. So decorators were originally introduced as part of the TaskFlow API, and they let you write your DAGs more functionally and with less boilerplate. This this whole webinar is being recorded, and you'll get the recording sent to you afterwards, as well as all the code and DAGs that are going to be presented. So without further ado, Kenton, take it away.
Awesome.
Oh, sorry, one more thing. You can ask questions live during the webinar, and we'll answer them either throughout, or if you want to wait to the end for the Q&A, we'll answer them on video then. So sorry, now without further ado, Kenton, please take it away.
Awesome. Thanks, Benji. Always have to get through the housekeeping. Yes, we definitely want to make sure we answer all of your questions as we go throughout. You can use the Zoom Q&A feature for that. It's a little easier for us to keep track of, but Benji will also be keeping track of the chat as we go through. Throw your questions and comments in there as we go. And with that, I will go ahead and dive in. So as Benji said, today we're going to be talking about decorators in Airflow. This is a great topic, kind of more on the DAG authoring side of things. It's something that we get a lot of questions about here at Astronomer and see a lot of questions out there in the community, but it's a really cool feature in Airflow. So we're excited to dive in and show some examples on how to use that. I'm going to start off with some slides that can walk through some background and talk about what decorators are and when you might want to use them, but then we will spend the predominant amount of time going through some actual DAGs and some code and some examples, so you make sure to get kind of that hands-on demo there. Go to the next slide, get on the right screen. So I'm not going to spend a lot of time giving background just on Airflow. I'm assuming that most people who have joined have at least some background on Airflow. And know what it is. Obviously, source tool, kind of the de facto standard for data orchestration. But one of Airflow's kind of core tenets is that you are programmatically authoring and monitoring your data pipelines. So everything is written in Python. And because all of your DAGs are written in Python, that gives users a ton of flexibility over how you define your data pipelines. So that's kind of the basis for what we're going to be talking about today. That kind of programmatic definition and using Python is a big part of what makes this kind of core functionality and extensible framework as kind of the two of the main benefits that we see of Airflow. And decorators kind of fit right into that as, again, just another tool in your toolbox, one of many for when you're authoring your DAGs. So again, kind of with some background there, decorators fall under the banner of DAG authoring in Airflow, which means kind of how do you go about implementing the logic that you need within your data pipelines in your DAG file. Usually, again, everything is written in Python, and Python is a super flexible language. There's a ton that you can do with it. And with Python, there's often many ways that you can accomplish the same thing, right? And Airflow is no exception there. So at Astronomer, we always recommend that you make use of kind of first-class built-in Airflow features for writing your DAGs. We consider that best practice. Just helps you, one, not reinvent the wheel, and two, use features that are highly tested by the community and developed by the people working on Airflow, so that you have to do less of that yourself. But even when using those features, there are often still multiple options, which is a great thing. But it can also mean that ecosystem is pretty big. And so it can take a bit of time to learn everything and sort of figure out what method of DAG authoring is going to work best for you and your team. So in general, things that people consider when authoring DAGs are your use case. So what are you trying to implement? What features are available for implementing your specific use case? A lot of it honestly is developer preference. So what style do you like to work in? People will also often think about things like code efficiency and code readability. All of those things kind of fall under, again, that DAG authoring umbrella. It is less about sort of functionality specifically, so as we're going to talk about again, there are often multiple ways to get at the same functionality. So this is going to come down to just with which method you want to choose. So decorators were introduced in Airflow 2.0 as part of the TaskFlow API. They are a different way of authoring your DAGs. And we're going to talk more specifically about what those definitions are and what I mean when I say different from, what came before. But in general, they can simplify the DAG authoring process. As Benji said earlier, they eliminate some of the boilerplate code required by traditional operators. So again, kind of a different style of defining your functions within Python. I just saw a question in the chat about whether decorators are available pre-Airflow 2.0. They are not. So this is a Airflow 2 plus feature. So if you're still on Airflow 1.10 or 1.x, we would definitely recommend upgrading both to get use of things like decorators in the TaskFlow API, as well as many other features. So yeah, you do have to be on a newer version. And so some definitions. So I've already said a couple of times decorator. I've also said traditional operator. Want to level set on what those things are, because we're going to use those terms a lot as we go through today. So decorators are actually a term that originates in Python, originates in coding, I should say, not necessarily just Airflow. So in Python, a decorator is really a function that takes another function as an argument and extends the behavior of that function. That's a bit vague and confusing. You honestly don't need to worry too much about that in the context of what we're going to talk about today. Although if you're less familiar with that style of writing Python code in general, there are a lot of great resources out there. If you just Google Python decorators, that can give you some background on that. But in the context of Airflow, decorators like the task decorator, and so you'll always see them start with that @ symbol. It's how a decorator is defined in Python. They're going to provide a simpler, cleaner way to define your tasks and DAGs. So we're going to go through that in depth. On the other hand, we contrast decorators by referring to traditional operators, which are essentially any Airflow operator that is not a decorator. So anything that you're used to using, like the bash operator, Python operator, etc., those are what we're going to call traditional operators. So most DAG authors are going to be used to working with those, especially if you're working with Airflow pre-Airflow 2. And so let's talk for a minute about why you would want to use decorators, especially if you're used to using traditional operators, maybe you already do. Why would you want to either switch or incorporate decorators partially into your DAGs? There's a couple of main reasons. Again, I've said this multiple times and we will actually demonstrate how this is the case, but it creates easier to read DAGs with less boilerplate code. So you will require less code overall to define your DAGs if decorators work for your use case. So that is generally considered a good thing. You also get some benefits from decorators being part of the TaskFlow API. And again, we'll talk through explicitly what this means, but that's things like inferred task dependencies and automatically passing data between your tasks using XCOM. So that's some of the boilerplate code that you're going to eliminate because those things are going to happen automatically. So that's a really big benefit there. It's just easier to manage kind of the flow of data through your tasks when using decorators. Another benefit is that for any folks who are used to developing in Python, but who are newer to Airflow, this might be a style of DAG that's easier for them to pick up. So there's less sort of Airflow specific knowledge that you have to have because a lot of that boilerplate is removed. So some teams that are migrating to Airflow, like from other tools, if they have people with a lot of Python experience, find this sort of method of DAG authoring easier to pick up. But again, generally, I'll say that it's a matter of developer preference and style, not functionality. So we're actually going to show some examples of like the exact same DAG using traditional operators and then using decorators. With sort of one exception that I'm going to talk about later in the webinar after the demo. Anything that you're going to define with a decorator, you could also define using a traditional operator. So we're not talking about sort of different functionality, just different style. So the next big question is what decorators are available. Importantly, you can't use a decorator for every operator that you would use. They don't exist, at least not yet, for every single operator. So these are the ones that are currently available that most people use. In general, the most common pattern for when folks use decorators and that I'm going to show today is if you use a lot of Python operators. So the @task decorator is the Python task decorator. It's going to replace the Python operator. Obviously, like lots of people use more specific operators and there's great reasons for doing so, but we do consistently find that, Python operators are the most commonly used in Airflow. So lots of people have at least some Python functions that they're running as tasks that they could use a decorator with instead of using the Python operator. You also have a DAG decorator just for instantiating your DAG. It's also a little cleaner. We'll look at that. That can be used in any DAG file. And then there are a couple of other ones that have been released in Airflow 2.1 and 2.2. So I didn't note this here on this slide, but do be careful with the last three here on which Airflow version you're on, because they were post Airflow 2.0 releases. So if you're running 2.0, you might not have access to these. So if you're on, the latest release of Airflow, like a 2.3 release, you definitely will have all of them. So something to watch out for. But there is also a virtual environment decorator for if you need to run tasks in a Python virtual environment, as well as a Docker operator. So again, that's going to run a Docker container with an image for a task. And then you do have a task group decorator. So we're going to look at that one. So if you want to stay totally in decorators and you're using Python operators, but you want task groups for that UI grouping, you have that available as well. Cool. So how do they work? Implementing decorators is super straightforward. You can simply add the @task before any function that you want to turn into an Airflow task. So I have a very quick little snippet here, but from that, we're going to move into a demo and actually walk through how a lot of these things work. So with that, I'm going to switch over to my Airflow environment here to walk through some of these DAGs. And I mentioned at first that I wanted to talk about kind of the difference between using decorators and traditional operators. So again, with like the Python task decorator, you're not getting different functionality per se. Anything that you can do with it, you could also do with the Python operator. But it's just going to be a different style. So to highlight kind of where the benefits are going to come and what the stylistic differences are, we're going to take a look at the same DAG, but written first with traditional operators and then written with decorators. So let's take a look at this classic DAG here. I'm going to pull up the graph. This is going to be pretty straightforward. So we have three tasks here in sort of an ETL type format. So an extract task, process data task or transform, and then a store data task. So it'll load. And I'm going to switch over to my code editor here. It's a little easier to read. Let's make this bigger. And so first we're going to start with this classic Python operator. So this is the code that's powering the DAG we just looked at. So we'll walk through this again, pretty simple for this example. I'm going to have three Python functions. So one for my extract data, one for my process data, one for my store data. There's not a lot actually going on in these functions. Again, it's just pretty straightforward example. However, you will note that I'm going to pass data through this flow of tasks. So process data is going to take the result of extract data, and store data is going to take the result of process data. Most of you, if you're familiar with working with Airflow, especially Airflow 1.x, you'll probably be familiar with kind of how this works. So my extract data, I am going to define my data string. I'm going to load it into JSON, and then I'm going to return it, which means down here, when I actually call my Python operator, that's going to get sent to XCOM because it returns a value. Then in my next task, you'll notice I'm passing in the task instance context, and that's because I want to use the results of that extract data task in the next one. So I'm going to do this XCOM poll, and I'm going to give it that extract data task so that I have that data dictionary here available for me. And then doing some processing with it. So I'm adding all of these numbers up to get a value. And then I want to return that value, so I'm going to push it back to XCOM. Then I do a similar thing in this store data task. So again, I'm going to pull the value from the previous task, this process data, and then I'm just going to throw it into a print statement here, defining my DAG. And then I have my 3 Python operators where I pass in my callables and I define my dependencies. So we're at like 45-ish lines of code. Not that bad for what this is. Again, this is how you would define a DAG like this pre-TaskFlow API, or if you're not using Decorators. But let's take a look at a different way to write this and to kind of highlight how we can make this a little cleaner and easier. So I'm going to hop over to this TaskFlow.py. And I'll note that before we go through the code here, this is the same DAG. So if I were to look in the UI, oops. Sorry, 1 second. Too many Chrome windows open. This one. Okay. So we'll go back to my Decorators ETL. Again, look at the graph. So you can see same 3 tasks. So we're implementing the same flow in this DAG. Now, if I go back to code editor, all right, back and forth here. Let's look at the code definition for this. You can see automatically this one's a lot shorter. I'm not gonna have to scroll at all. We're defining the DAG using the DAG decorator. So this one is not gonna be a huge difference between defining your DAG not with a decorator, but it is a little shorter, because you can just say @DAG. Then I'm going to go through and give it all of my DAG parameters. If you have default args or things like that, you can throw those in here too. Anything that you would normally pass into your DAG function to instantiate it, you can still pass into this decorator. Note that when you do this, define DAGs or tasks using the decorator, you do have to then call those functions. So for the DAG level, that's what I'm doing down here. So I define the function. This is my DAG, in which I will define all of my tasks. And then in the last line here, I actually call that function and assign it a name. So Decorators ETL is the name of my DAG. This is an important part to remember, because if you only have the decorator, if you only have this line, Airflow won't actually register it as a DAG. So you'll have this great code and then you'll be looking in the Airflow UI and it won't show up, which is obviously not helpful. So you have to make sure that you have that piece. So that's the DAG decorator, straightforward there. And then for the tasks, so again, using the task decorator, all you have to do is add this @task before the Python function that you want to turn into your task, and Airflow will go, okay, I know that this is a Python operator task and I'm going to turn it into one. So you no longer have to explicitly call the Python operator as you did in the previous DAG. So that's part of what saves you that boilerplate code, is just in this one decorator, you're saying this is a task as opposed to a whole separate thing where you pass in your callable and everything else. The other thing that you'll notice when you define the functions is that this one is basically the same. So I'm still extracting my data, turning it into a dictionary and returning that. But then if we look at my transform task, you'll notice this one is quite a bit shorter. And part of that is because I don't have to push or pull anything from XCOM. That is handled automatically for me using the TaskFlow API. So that's one benefit to defining DAGs in this way. Again, that's going to save you on that boilerplate code, is now when I actually call these functions and tell Airflow like, hey, these are dependent, all of the data that is in the dependent function, so the upstream one, so in this case, the extract data is going to automatically be available in the downstream task. So you don't have to worry about explicitly pulling that. And then same thing with my last task. Now I just have my print statement. I still have the total order value as that's what I'm going to, that's the input to this function that comes from the transform task, but I don't need to explicitly pull it from XCOM. And then finally, I have where I actually call all of these functions. So again, this is super important. If you don't have this line, your tasks won't show up. You'll just have an empty DAG, not helpful. But this is also where both the passing data happens and also where the dependencies are inferred. So again, you'll notice no bit shift operators to say this task has to come upstream of this task. That's all inferred from calling the functions like this. So I start actually with my extract data task, which is in here. That's passed into the transform task, which tells Airflow, hey, extract has to happen before transform, and the outputs of extract data are going to be needed by transform. That's all inferred from calling the functions in this way. And then that gets passed to the load data. You'll notice in this case that I'm not actually returning multiple outputs here, but I do have multiple outputs set to true, which is why I specified this is the output that I actually want to pass to the load function. So you can do that if your functions return multiple things. Other things that I will note about TaskFlow API that are kind of common questions when defining your tasks in this way are you can pass other sort of high-level parameters into the tasks. So for example, if I want to change my task ID, so by default, the task ID will be the name of your function. If you want it to be something else, like in this case, I called it extract instead of extract data, you can just pass that into the decorator. If you want to override a default argument in your DAG, like in this case, I'm saying retries for this particular task are going to be 2. You can pass that in as well. So common question that we get, again, since decorators don't have the same sort of parameters as a traditional Python operator, but you can pass them in here. That's true of anything that you can pass into the base operator. You can pass into the decorator here. Same with the multiple outputs. If you don't have anything to change, you can just leave it empty. Cool. So again, kind of result of this DAG is that we have less code overall. It's easier to read, at least in the opinion of a lot of people. If you're used to using traditional operators, some people find it takes a bit of time to get used to defining DAGs in this way. But certainly if you have everything in Python operators, this can be a super helpful way of defining DAGs. I have a couple of other examples I'm going to go through, but I want to pause there. Benji, are there any questions kind of related to what I've covered so far? This was a lot of information. I want to let it digest and answer anything that's pertinent before we move on.
Yeah, so I think there are a few good questions that we should look at right now, which the first of which is Robert asked, how would I set the executor config for the task decorator? With the Python operator, it's just a parameter to the Python operator. So you'd have Python callable equals function, and then executor config equals a dictionary. And you were just talking about how the task decorator parameters are a little bit different. So
yeah, so that's like if you're using the Kubernetes executor and you're passing in the config to the operator. Yeah, so you should be able to just pass that in to the decorator, I believe, just like you would any parameter. So any parameter that's part of the base operator, which I believe the executor config should be, since it would apply to any operator if you're using the Kubernetes executor, you should be able to pass in just to the task, I think. Yeah.
Great. A couple other quick ones. Could we just go over what the current decorators that are available are again?
Yeah, for sure. Let's hop back to slides real quick so I can refer to where they're written. So these are the available ones currently. And again, this list is as of 2.3, Airflow 2.3. So note that some of these were released kind of throughout the most recent 2+ releases. Some of them came into 1. I think one of them came into 2. So you have your DAG, which I've shown. That task decorator is for Python operators. You also have virtual environment for, again, that's Python based virtual environment. You have Docker for the Docker operator. So that's if you want to run a container. And then you have task group, which I'm going to show in just a minute.
Great. And then let's see a couple more quick ones. And also just, do we have other task decorators on the horizon that you'd like to talk about right now?
Yeah, so we're going to talk about that a little bit more at the end. But yes.
Okay. Let's see. I think there's one more that might be good to answer now. So we answered how to use other operators besides the Python operator with TaskFlow API. These are the ones that are available, and we're going to talk about ones on the horizon a little bit later. Is there an example of how to set a task decorated task that doesn't return a value downstream or upstream of another task?
Yeah, that's a great question. So if you just had like a standalone task without any dependencies, yeah, you can definitely do that. In fact, I don't think I have an example that does that, but if I were to just comment this out real quick and do load, that's all you have to do. So you would just call the task independently. In fact, this is probably going to throw me an error because I have some inputs into these. Well, maybe this will work without the transform. But if you had like independent tasks in your DAG, this is all you would do. You would just call the functions, and you can call them separately, and that should result in, yeah. Not going to work in this particular one because I've set them up to pass data throughout, but that's all you have to do to get independent tasks that don't pass anything.
So, okay, so we have a related question. For instance, if transform didn't return a value, how do we set load downstream of it? And this also goes into mix and matching task decorated and non-task decorated operators. You can still order the operators the way you would with a bit shift or with a chain.
Yes, yeah, that's exactly right. And so I'm going to show an example in just a minute of how you would incorporate like a traditional operator into the same, into a DAG with that is using TaskFlow and decorators. But with any of these, even if you just have decorators throughout, like if you don't need any of the other benefits of TaskFlow, you can simply like do it with bit shift operators like this. Something like that. And like I said, I have some examples that work that will show that in just a minute.
Great. Well, why don't we move on? I can keep answering some of the questions on the side here, so please keep them coming, and hopefully a lot more will be answered as we dive into this next example.
Awesome. Thanks, Benji. Yeah, great questions, everybody. Okay, so like I said, I want to move on with a couple of other examples here to show. So this was kind of the most basic. Again, showing where every task in my DAG is a Python operator, and they all sort of flow one to the next. Pretty straightforward, just 3 tasks here. But a lot of times, again, because we've gotten a lot of questions about which decorators are available, some folks will be working with DAGs that only use Python tasks, in which case, if you want to use all decorators, that's great. Oftentimes that won't be the case. So maybe you don't have only Python functions in your DAGs, or maybe you want to keep using, traditional operators so that you don't have to reinvent the wheel and write your own Python function for something where a specific operator already exists. You can absolutely mix them. So that's what we're going to show in the next example. So I'm going to look at this mixed ETL. Let's look at the graph here. And this is actually the same DAG that we were just looking at, except for I've decided that in this one, I want to send an email notification at the end, and I'm going to do that using the email operator. So again, simple example here, but I do still have this dependency. So let's take a look at this DAG. So that's going to be my decorators and traditional. So you notice the whole first part of the DAG is going to be the exact same one that we just looked at until I get to here. And then I have my email operator. So traditional operator, I'm going to add it into my DAG just the same as I normally would. Note that if you have, if you're defining your DAG using a decorator, you do want to make sure that any operators you define, be they decorators or traditional, come within the context of your DAG function that I just minimized. So mixed ETL in this case. Otherwise, if you put this, at a different outside of that context, then Airflow is not going to recognize that it's part of the DAG, and you'll probably get an error there. I think when it tries to import. So again, I'm going to use this just as I would the operator in any other case. And then for defining that dependencies, again, for these other ones, I have my 3 tasks, again, that are passing data between each other. So I'm defining them just using the function calls there. And then I'm even going to mix the bit shift operator in with that. So this is totally valid. So I can now say email notification is going to come after all of that other stuff. And again, that results in this DAG. So that's totally valid. One thing to note is, say you had a case where you were using a traditional operator and it was going to come in the middle of your DAG. So instead of at the very end like this, that's also totally fine. You're just going to end up defining more dependencies using bit shift like this. If you are going to move from, say, a decorated task to a, or I should say maybe in either direction, either from a decorated task to a traditional operator or the other way around, and you do need to pass data between those 2 tasks, that is not going to be handled automatically by TaskFlow. So this kind of flow here through these 3 tasks where I don't have to explicitly define any XCOM, it's all inherently determined through this definition here. That's only going to work for in the case where everything is defined in Python using these decorators. So if you had to mix in traditional operators, say for like this transform task, you can totally do so, but you're going to have to add that explicit XCOM pull within your operator. So something to keep in mind there. But otherwise, again, pretty straightforward. You can totally mix them. There's no need to like wrap an operator in a decorated Python function. We've seen that. They are designed to sort of be mixed together. So you can go through and just update your Python functions and then use the other operators as needed. Cool. And then the last example I want to show here is of the task groups decorator. So this one is going to be a little more complicated. So task groups, again, another Airflow 2.0 feature that are a UI grouping concept. They're super nice if your DAGs are quite complex and you want to simplify kind of how they're viewed in the UI. They can really help make it easier to see what's going on in your DAGs. In this particular case, they might not be strictly needed because I've only got 4 tasks in here. But imagine if you have hundreds of tasks in your DAGs. We use these internally at Astronomer a lot for some of our more complicated DAGs that manage our internal data. They are super helpful. So there is a decorator as well for task groups, which again can just help kind of simplify how you're defining your DAGs and make that DAG file cleaner. So in this particular DAG, we're going to look at the code for it in a second. I've got this extracts task group. So if I expand it, it has 4 tasks in it. And then I'm going to move on to a transform task after that. So we'll hop back here and take a look at the code for this one. That's the wrong one. Task groups. Here we go. So in this case, I have kind of a similar DAG. I'm extracting some data, except for in this case, I'm defining my strings up here. So instead of just one string of data like I had before, I now have 4 different ones. And I want a different task for each one of those. And I want it to, I want them all to be in a task group since they're all doing basically the same thing. So I'll note that in this particular example, I am generating these dynamically within the task group. I'm using a for loop. You don't have to do that. They can be totally static. But the way the task group decorator works is basically you have to already have your tasks defined. So in my case, I am defining them here, again, using this for loop. So I'm looping through these data strings and I'm creating an extract data task for each one. This is the same function we were looking at before. And then your task group is going to basically have a function that then needs to call all of the functions for the tasks that need to fall within the task group. So I'm doing that by kind of nesting these functions here. Doing this, and then I call them down.
And let me ask a question about this task ID in the for loop. So that extract _0 there, and it's formatted with the data string. That's going to give us a unique task name for each one. So you'd have extract apple, extract carrot, extract banana, extract orange.
Correct. Yeah, so that's exactly what they show up here. You don't have to do this. So if, so what this is doing basically, so I'm looping through the entries in this dictionary. That's called data strings. So that's my loop here. So basically what I'm saying here is I'm just dynamically assigning a task ID with the data string that gets passed in so that I have that unique ID. You do have to have a unique ID for your tasks, otherwise Flow gets confused. You don't actually have to do this. So if I were to just get rid of that and just say extract and save it, Airflow will assign like an underscore. This has been, there we go. So you see I have the first one, and then when it loops through, it says, oh, I already have an extract, so I'm going to add this __1, 2, 3. So you don't have to add something like that. It's just for this example, it makes it a little clearer. But this is, I would say, a highly use case specific the way I've done this here. So you may or may not have something like this in your DAG. Yeah, good question. The other thing that I'll note here is, again, for this task group definition, you don't have to be, looping through to define the tasks. As I do here, I just put this together in this example to sort of show, one, how you do this in syntax, because it's a little more complicated, and to highlight sort of pulling a couple of different similar tasks. In general, the syntax that you would use for the task group decorator is to do the @task group, and then you have your function. I wouldn't actually call it function, and then you would call the functions that you want in the task. So that might be just like extract tasks, transform, something like that. If you wanted these two, if you just had a single extract task and transform in there. So you can do something like that as well. You'll notice then down here that I define my dependencies here between the extract tasks and the transform using bit shift operators. That's because my task group itself does not return anything. So again, with that function, while my extract data tasks do return a dictionary, the actual task group function itself, which is this one, does not return anything. So all it's set up to do is say, these are the tasks in my task group. So I'm using bit shift here. This is an example of what you can do in general if your tasks don't return anything with decorators using TaskFlow. You can always define them like this if you'd prefer to, or if you don't need that functionality that comes with nesting the function calls. So yeah, an example there.
We have some more questions. If we want to go through a few more right now.
Yeah.
So a few people are wondering how multiple outputs work. And if you can have multiple outputs from a task, how do we handle them downstream if we want to redirect to different tasks?
Yeah, that's a great question. So let's look at TaskFlow example. So in general, multiple outputs, you would, if your task has multiple outputs, you define that like this in your task. This is a bad example, I'm realizing, because somewhere along the way I lost the second output here. But let's say you returned output 2, and that was, we'll just say total order value again. But maybe you have another variable here that you're passing through. So I return multiple outputs. Then the way I reference in a downstream task, and I say, okay, one of them I want total order value, the other one I want output 2, is you can do that using TaskFlow. So that's why you see here with this is related to the transform function. So I'm pulling this specific variable and saying, that's what's getting passed to load. And you'll see load has one parameter that it's expecting. So if I were to take this out and have multiple outputs here, this would actually throw an error, because it would say, hey, load is only expecting one thing and you passed it 2. You could do this with, so you can specify, hey, I only want one. You could also pass both, and you would probably want to define them by name, unless they happened to match up. You can also do something like this, where load gets this particular value, and then maybe I had another function that was load again, and that takes transform of output 2. So something like that. So obviously I don't have a load again function in this case, but what you would get from this sort of dependencies defined in this way is you would have 2 downstream dependencies from transform. So that would split. That would be parallel, load and load again. And load is going to take this value. Load again is going to take this value.
Thanks. And then just more broadly, multiple outputs is returning multiple different outputs, for lack of a better word. Is that as a dictionary, or can we unpack those, having something like result 1, comma, result 2 equals function?
Yeah, so you have to remember that this is all using XCOM. So XCOM is only going to take sort of a value that is JSON serializable. So you do have to be kind of careful about what data type you're passing it, or it will throw an error. It's possible you could get around that if you turn pickling on, although I, to be honest, haven't tried that in this sort of format. So that could be something to play around with, but you should, it doesn't necessarily have to be a dictionary like this, but it does have to be a valid XCOM format.
Okay, we have a follow-up question here. So in theory, if load was expecting only one parameter and multiple outputs was not required, you don't need transform to pass anything to load.
If by anything you mean this value, then yes. So for example, if this weren't true and I just had the one value here, and in that particular case, I could get rid of this, if that's the question. Yes, that would be valid.
Okay, and then
kind of like the first one does. This one just returns 1. Yeah.
Okay. And then we have a few questions about XCOMs and passing things around. So can task group return an XCOM?
Yeah, so I believe I'm not totally sure on that. I believe so, that you could define that in the Python function, but I haven't tried it yet. So yeah, that is something that that I'm going to look into and potentially update this example. So stay tuned with the repo that gets sent out later. The other thing you could also do with task groups is if the task, this is not quite as clean, but like if the tasks in your task group return something, which in this case they do, you can always just explicitly use XCOM in the downstream task to pull those. And that might be cleaner depending on sort of what's going on in that task group and whether all of the tasks are returning something that you have to like aggregate, or whether they're, you know, one of them is returning something, you need that, but the others do not, things like that.
Okay.
Yeah, good question.
I'm going to answer two of these real quick. Does this mean I can use this to group extract tasks from example 2 source systems to an S3 bucket? Yes. You should be able to do that. Kendon?
Mm-hmm.
Okay.
Yeah, you can have anything in that function that you want to have in there.
Great. And then can tasks handle passing large data sets as input and output? This is a really good question because the answer used to be no. The answer is now yes if you're using a storage backend.
Yeah.
So if you have GCP, GCS or S3 or Azure Data Store, anything like that, as long as you have an actual backend system, the XCOMs will push and pull to that backend, so you can store large data sets there now.
Yeah, that's a great point. I would say anytime the data you're passing between tasks is pretty large, proceed with caution. Don't overload your metadata database. Using an XCOM backend is a great way to get around that. And we do have resources on how to set those up if you're new to something like that. So cool. I'm going to hop back to our presentation here and talk, since we're getting close to time, about kind of other potential features to look out for and other decorators in the future. So I'm going to hop into that, and then if we have time at the end, we'll answer any additional questions, or Benji can get those in the chat. Hopefully everybody has seen kind of some of the value that decorators can provide. Again, as we've talked about multiple times, they're a little bit limited in terms of what you can do with them, just because they don't exist for every operator. So you can mix and match, but you don't necessarily get that same task flow experience. In terms of upcoming features, the Airflow community can always contribute more decorators. So I don't have a specific answer on which operators there might be decorators for in the future, but definitely take a look at the Airflow project repo if there are issues or requests for ones, they might show up in there. And definitely as I mentioned, a couple of the decorators that are now available have been released since TaskFlow API was originally released in 2.0, so definitely upgrade your Airflow kind of as new versions come out. The other upcoming feature I want to touch on just super briefly is the Astro SDK, which is an open source DAG authoring tool that's maintained by Astronomer that contains exclusively decorators that can be used in your DAGs. It's currently in a preview release state, so this is why I'm not spending too much time on it. It's not production ready yet, but it is open source and definitely something related to what we're talking about today. So want everybody to stay tuned for more updates kind of as this project reaches maturity. But basically, the Astro SDK is going to allow you to write DAGs based on the movement of your data, and it simplifies the data transformation process between different environments. So it allows you to both use decorators, but also, again, remove a lot of that boilerplate so that you can focus on just writing execution logic and not so much on that Airflow orchestration logic. So just as a quick kind of teaser example, these are going to use, again, decorators that are come as part of the Astro SDK. So that's a separate, Python package that you would install into your Airflow environment. It allows you to switch pretty seamlessly back and forth between, say, SQL and Python. So that's what this DAG is doing here. I'm doing a couple of transforms on some data, and you can see I'm going from filtering orders where I just pass a SQL statement. Then I'm doing another join order customers where I'm just passing a SQL statement. And then I move into a Python transformation where I'm using a data frame decorator instead. And these are all flowing one after another. So I don't have to explicitly put code in to convert the results of a SQL query into a data frame, which again, just ends up being a lot of boilerplate. It's kind of messy. So it can really speed up your transformations as you're moving through. Very relevant to what Benji was just talking about with kind of passing larger amounts of data and using backends. The SDK handles all of that for you. So if you have a backend of, say, Snowflake or, say, Redshift, everything intermediary between these tasks is going to be automatically handled for you. You don't have to specify anything. You don't have to define the connections a bunch of times. Anything like that. So if you are interested in kind of using decorators in your DAGs and you do a lot of your data transformations or data pipelines in Python or in SQL, this will be a super helpful tool. We will have additional kind of educational sessions, so webinars and written guides and things like that on this later in the summer as, again, the project matures. You're welcome to check it out now. But again, it's not quite GA ready for production yet, but something to keep an eye on if this is of interest to you. Cool. And then with that, I think that was all I wanted to cover. That was a lot of information. So we love seeing people be really engaged on all your questions. We have time for maybe one or two more questions, if there are any, Benji, that you haven't gotten to.
There's one more that just
okay.
came up that I think we could answer, and then we'll have to call it. Based on that snippet, this AQL one here, it looks like AQL is meant for using Airflow to perform the ETL itself rather than simply scheduling and orchestrating. Is that accurate?
Yeah, exactly. So instead of, orchestrating transformation that is happening elsewhere, you are using Airflow to do that transformation, which is part of why Benji not just with this project, but was saying that, old story in Airflow used to be you don't want to do any of that processing or passing data within Airflow because it wasn't built for that. That's becoming no longer true with sort of new Airflow features, and this is one of them. So again, it does sort of simplify that experience if that's kind of the use case that you're going for. Cool. Well, thank you again to everybody for joining. I hope this was helpful. As you both said at the beginning, we will be sending out the recording as well as the code that I went through today, so you can use those as examples. Definitely, if you have additional questions that we didn't get to cover, feel free to reach out to us. We're always happy to help. Happy to talk to everybody about their Airflow experience and how it can be better. We're super excited about these new features, and we will be doing more kind of content, again, as I said, on these things in the future. But with that, we are about at time. So yeah, thanks everybody for joining. We hope you all have a great rest of your day.
Thanks, everyone.
Bye.
Bye.